do it this way because it's the full screen is not letting me do this and play nice today. So just bear with me. So we just finished with the modern periodic table, predicting the products before they were done. Now we're on to the modern table. I know it's a little smaller, but it'll work all right for what I need today. So these things, these elements are grouped based on their properties, like Mendeleev discovered. Similar properties are always in the same column. Column means vertical, up and down. All right. The order, according to Mendeleev, was by atomic mass. Okay. We put it by atomic number now. And if you look at elements like 52 and 53, tellurium and iodine, they have their masses are slightly out of order, and that's okay. All right. What we focus on is that we didn't know tellurium at the time of Mendeleev, and so we had to adjust the order a little bit. So this modern periodic table, still based on properties that Mendeleev found, but now instead of being atomic mass, all right, it had atomic number instead. Now, we also added a column of elements Mendeleev didn't know about. These are going to be the noble gases. These are going to be the things all the way far to the right. The reason why he didn't know about them was because A, they were gases. We didn't study a whole lot of them at the time, but B, they didn't react with anything. And we're going to talk about why that is in a little bit. All right. But just understand that's a column that Mendeleev didn't know about. And so he didn't have it on his periodic table, but we have it on ours. All right. For where we look at and all that kind of stuff. All right. So, first thing we want to talk about, this thing is just not being nice today. All right. I'm trying to go on to slide 6 here in our notes. I don't know why it's not working. There we go. All right. Is that there are 7 horizontal. Horizontal means side to side. All right. There are 7 horizontal roads, and these are called periods. Now, these have to do with the stuff we've talked about, that they have to do with the energy levels. So there is our 2 in the first shell. There's our 8 in the second shell. There's our 8 in the third shell. There's our 18. There's our 18. And then these things fit into these last 2 categories. So this would be 32 and 32. All right, this periodic table on this thing's not nearly as advanced as the one you guys have because we're up to 118 now. So this should go all the way to there. All right, but there's 7 of them. So this is period 1, period 2, period 3, period 4, period 5, period 6, period 7. Just you can number it right here 1, 2, 3, 4, 5, 6, 7. All right. So basically, what we do is we treat the periodic table like a map. If I ask you what the third element is in the 4th period, you would go 1, 2, 3, 4, and go 1, 2, 3 over, and that should be scandium number 21 would sit right here. So you can just kind of find it based on what those things are. Now, periods are not that important. They are massively important as to what energy level you're in, but they're not that important as to why these things are the way they are. Okay, because that's going to be more with why they're stacked on top of each other. And obviously these are horizontal, so not worried about the stacks. Okay. The vertical columns, the up and down columns that are here on your periodic table, all right, are called groups. Again, this thing is just being really mean to me today, not letting me advance. There we go. All right. So in this group, okay, there are 1, 2, and then look all the way here, blah, 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 all the way here. There's 18 all the way across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then all the way up to 18 across. So you can go and look. It even says it on your periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. And then 13, 14, 15, 16, 17, 18 up at the top. Okay. These are called groups. Sometimes these are also called families because families all, whether you like it or not, they all act alike. Okay. And so everything in this, well, we're going to ignore this one for right now. Everything in this first group right here acts alike. Everything in this group right here acts alike. In this group right here acts alike. In this group right here, and especially in this group right here, they all act alike. So we call them families. So this could be family 1 and family 2, family 18, all this other kind of stuff. Okay, so we're going to look at some specific things and stuff we want to talk about on your periodic table. And again, when I show you this, I want you to color it if you want to. You don't have to. All right, I would like you to make it easier to follow later on, but we'll see where these things are. Okay, now if you look on the top of your periodic table, you have some Roman numerals. Roman numerals will tell you a lot of stuff that you need. Okay, but if you don't know what Roman numerals are, I is 1, and Roman numeral II is 2, and Roman numeral III is 3, etc., 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 all the way to V is 5, and etc. These are called the A representative elements, these groups. So this is 1A and 2A. We skip all these things right here. These are going to be called the hate box later on. 3, 4, 5, 6, 7, and 8. Now it says that on top of your stuff. It says 1A and 2A, 3A, 4A, 5A, 6A, 7A, 8A. Those are the A elements. All right, as you guys get into those things, you look at what those things are. Okay. Now, as you go through and look at this stuff, okay, there are other things that I want you to do. All right. Notice that these are all different colors, and I would like you to do that. I would like you to color this family one color and this family one color, and especially this family and this family. You don't have to do all of these, okay? But I especially want you to color group 1, group 2, group 7A, and group 8A. Those are very, very special families that you guys are going to see as we go through this, okay? The things in here are called the B elements. Now we're going to call them the hate box later on, but they're the B elements for what we want. How another way that your periodic table is set up is with metals versus non-metals. And so this line, which again, I will show you in a little bit when I show you the actual periodic table and I draw stuff with you, I want you to put on your periodic table, make it nice and dark, because everything to the left of that line is a metal. Everything to the right of that line is a non-metal. So what makes a metal a metal? All right. Well, if you look at what makes a metal, it's pretty easy to understand. Okay. Metals have specific properties, and you guys know this. Right? You guys are pretty smart. Okay. Metals are shiny. This thing isn't working over for me right now, but they're shiny, so they have luster. They can be drawn into wires like copper wire, so they're ductile. They can be hammered into sheets, and they're good conductors of electricity and heat. All right. But what they also like to do, all right, and you can add this in or whatever, is they also like to give up their electrons. Okay, they like to give up the electrons and they like to form those cations that we talked about before. Okay, now, next thing I'm going to show you here are the nonmetals. Nonmetals are the opposite side. We talked about group B before, so it's not a big deal. All right, group B before are dull, brittle, non-conductors of electricity. Again, if this thing would ever work for me today, I apologize. All right, you'll see how this goes. But anything to the right of the stair-step line, so follow my little arrow here because this is not turning over like I want it to, but these are all going to be your non-metals. All right, I don't know why it's not letting me do this, but non-metals are going to be dull and brittle. All right, there we go. Dull, don't have any shine. Brittle, they break really easily. They're non-conductors, they're good insulators, all that kind of stuff, and they're all the things over here. So again, we're going to show this stair-step line when we do things here in a second. I'm going to show you what all of these things are. All right, things to the left are going to be metals, shiny, hard, good conductor of electricity, dull, brittle things along here. Okay, these like to give up their electrons and form cations. These like to take in electrons, and so they're going to be those anions that we talked about before. Now, last thing we're going to get to today, or we're going to talk about today, are metalloids and semimetals. All right, semimetals and metalloids are things that are touching that stair-step line right here. I'm going to have you guys draw with me in a second. All right, and they have properties of both. Everything touching that stair-step line except for aluminum right here. All right, everything here along this stair-step line, all right, is going to be semi-metal or metalloid. And then one of the most famous ones is sitting right here, right there, and that's silicon. Silicon, if you guys know what silicon is the computer chip thing and all that other kind of stuff, but it's also dull and brittle and all of that kind of stuff. But it's a great conductor of electricity, so it has properties of both. Okay, so left side of the periodic table is metals, right side are non-metals. Things that touch the stair-step line are going to be semi-metals or metalloids. Okay, and that's enough